Good morning. Hi. I'm Lorna. Thanks for coming. I am super excited about serverless technologies, and I don't think the Python community necessarily knows how well placed they are to do amazing and interesting things with serverless technologies. So I thought we'd come and tell you, and because I was so keen to come back to PyCon now that I actually know some Python, which I didn't last time I spoke here, it was interesting, I put fun in the title to improve my chances of being accepted. So now I'm here and I need to provide some fun along the way. And in pursuit of this, I have brought a co-presenter. Alexa, how are you?
I'm fine, thanks.
Okay, so you have all witnessed that the demo did kind of work at an early stage. We'll be asking her to be our trigger for some of our serverless examples later on. And I'm just going to stand here and hope like mad that everything that is currently working keeps working, because this is kind of a crazy thing to use as a demo. So let's talk about serverless. I don't think it's an exaggeration to say that serverless is a revolution. This technology, this platform, will change the way that we create some of our applications forever. There are things here that will go into our toolbox to come out in the future. Sadly, it has a really stupid name because, as you can guess, right, it's code, it runs somewhere. It might be an imaginary server because it's kind of in the cloud, but there are definitely servers. In common with this no ops term that you hear, it's not no ops, it's rather excellent ops, actually, just done by somebody else. The idea is that we allow developers to really focus on the code and leave the platforms and the operating systems, the deployment, containers, and all the packaging to something else. So, back-end functions, write some function code, deploy it to the cloud. Just, here's my function. Here you are, cloud, have my function. And it will run in response to whatever you set it up to run with. So it might be somebody made a web request, which was wired up to your serverless function. Maybe something comes in, it's I can't say her name, it's her wake word. The Amazon Echo device just sends a web request. It's basically a webhook. But it might be an incoming SMS, it might be a job on a queue, it might be a change in a database. There are lots of things that would cause us to trigger a serverless function. If your function is working too hard and things find that it isn't available, then you will have more of that function and it will horizontally scale as required. Here is, in my opinion, the killer feature. You only pay when your function is running. If you deploy something and nobody uses it, it doesn't cost you anything. If you deploy something and a moderate number of people use it, it still doesn't really cost you anything because all of the serverless platforms have really generous free tiers. So you can do some pretty low traffic but used all the time stuff with these platforms. And it's not going to cost you anything to have a play and a prototype. So I think the entry level is really, you can all do this. If you're sat too far back, you stand no chance of seeing this diagram. I have uploaded my slides and tweeted, hopefully, if I've understood technology, tweeted a link to them. So feel free to put them in front of you if that's easier. But the basic idea is here that we have functions on this side. Now, because serverless is a new, shiny technology with lots of buzzwords, we can't just call them functions. People would think they understood the technology, and we don't want that. Right, that would be much too easy. So our functions are called actions. Some of the platforms allow you to package the actions together in groups, which I find helpful. You can either run, except we say invoke, big words, yeah? Invoke. You can run these functions from the command line, maybe in response to web requests, a bunch of other triggers also. So I've got feeds coming in, somebody uploaded a file that we need to process, all kinds of things can cause our functions to run. And what we're doing, you'll see this acronym, Faas, Functions as a Service. So as a developer, you supply the function, and the platform allows it then to be packaged and to run. As developers, and that's my background, we focus on what it is that we're trying to achieve, the output, the outcomes that we're aiming for. We think about the dependencies for that. What are the requirements? What are the inputs to achieve that output? And keep it minimal if you can. Charges are by the gigabyte second, so that's units of one function running with a gig of RAM for a second. Spoiler, they don't normally have a whole gig of RAM and they don't normally run for a whole second, but there we are. They're also time limited, so you cannot run long-running functions this way. Because of the way they are charged, we now value, once again, efficient code. We've certainly had a period where the hardware, like the server resources, were just a lot cheaper than the development resources. And so if it worked well enough, that was cool, and we just shipped it. This is slightly different, particularly once you scale it up, because inefficient code will add up in tangible money costs really quite quickly. I have seen serverless work really, really well in some particular use cases. So I'm going to try and share my sense of when this is a useful time to choose it. The most obvious, the most entry level is when you have a static website with one dynamic requirement or two dynamic requirements. It's just content, you're using some kind of static site generator, but you also need an inquiry form, a mailing list sign up, something tiny. You don't necessarily want to have to deploy a web server for that. Using serverless, you can make your form post to a serverless endpoint and have that process the data. Just deploy your static site to some static hosting. Particularly the occasional side of that, very low traffic, is much cheaper than running a dynamic web server all the time. For very variable traffic levels, serverless can also be good because it means that your web platform does not need to have the headroom for the potential incoming burst of traffic all the time. You can just have, it'll scale up as needed, and you're only paying for the resource that you're using. The flip side of that is also true. If your load is consistent and predictable, even if it changes over time, this is not going to be the most economic way to run this. Having a straightforward web platform where you know how much resource you need will be great. I mostly see this used for startups, things that you think could be massive, but you don't know yet, you don't want to pay for it all. Prototyping, because you don't really need permission. You don't need to set up new things or commission a whole new cluster. You can just ship it to the cloud, see how you get on, and maybe refactor later. The reason that the classic example for this is always image resizing, because it's quite a good example, actually. Crazy, I know. The hello world of serverless is resizing, thumbnailing, watermarking images. It's the sort of thing you don't want to do on your web server. It's the sort of thing that is easy behind some sort of microservice or third-party API. And whether that's somebody else's, well, it's literally a third-party API or actually like a first-party API, I guess it is, if you built that as a microservice, as a serverless component, then that's a really nice way of adding things in, adding functionality in to your application. Bunch of serverless platforms available. I work for IBM, they pay my hosting bills, and Amazon Lambda is at the top of this list. It belongs at the top of this list. Amazon were trailblazers in this space. Lambda came about to solve a problem that they really had. And I think most people who've played with serverless have begun in the Amazon Lambda space. That said, I work with the IBM Cloud. They pay my hosting bills as well as me, so that's marvelous. I also really like this offering. The IBM Cloud Functions offering is a hosted version of Apache OpenWhisk. So it's an open source serverless platform. If you are not deploying your stuff to the cloud, then you can still play with the serverless stuff on your own servers. Crucially, you can also run that locally, which makes development much, much more fun than pushing code to the cloud and waiting for it to upload. You get the picture. A few other offerings then. Most of the cloud providers will have something along these lines. So Google Cloud have a functions offering, Azure have a functions offering. My strong recommendation is that if you are already working with a cloud provider and you're interested in serverless, you try the offering of the cloud you're already integrated with. So on IBM Cloud, because we already have the runtimes, we have some container stuff, we have nice database offerings, it makes sense to put your serverless stuff onto the same cloud and maybe talk to some of the same services, use the same setup. Hopefully we're also already an approved supplier, which makes quiet prototyping very much easier in your day jobs. So let me actually show you around how to do this. If you are using Lambda, let's start with Lambda. If you are using Lambda, then you will need to install the AWS CLI tool. It gives you an AWS command that things will then follow. All my examples are command line because that is the way I work. You do not have to do this by command line if that is not your thing. I'm not sure why I'm trying to reassure you. I say that at JavaScript conferences, but Python people probably can manage. Okay. There are web interfaces. You can click, make me a new function, type the function in a nice text editor in the browser, whatever works. And most of all, whatever gets you started. On Lambda, you need to set up the permissions via their IAM system. You will need the Lambda permission. I'd recommend API Gateway and also the CloudWatch logs, just in case your code doesn't work first time and you need to do a little bit of debugging. The AWS configure command will bring those settings into your AWS command. Now we do the easy part. We write some code. So we have a Python file, and we add it to a zip file. Strictly speaking, for Hello World, you don't need to zip it. It is my hope for you that you will all go beyond Hello World, maybe write code that's longer than one file, maybe. Then you'll need to zip it. So we'll show the zip workflow just so you're all ready when that lands. To create your function on Amazon Lambda, AWS Lambda create function. Now set up all the stuff. So the function needs a name. It's a zip file. Lambda can't guess how to run it, so you're going to say what version of Python you want to run it with. The role there, that's the access control IAM stuff that I just mentioned. If you are Amazon native, this will make sense to you. If not, don't worry. Give it a description. Try and write some words here. Hopefully you'll experiment with more than one function, so some sort of meaningful label will be helpful. The -- handler switch is the entry point. So I had hello.py, and the function is called main, so you can specify where the start point is. Supply the zip file. This is to create. You probably need to iterate, like write some code, run the code, change the code, upload new code. So when you're uploading new code, the command looks a bit different. You're going to use AWS Lambda update function code. There is also update function config if you need to change any of the other settings. Say which function this is, supply the new code. Brilliant. To run it, we're going to invoke, big words, serverless. We will invoke our action. We don't run our function, that's for, AWS Lambda invoke. Say which function it is, specify where the output should go. So output.txt will give you the return of your function. So the code looks like this. Declaring a main function, it takes 2 arguments, the event, so if there's like a web request with some data, all of the context is in there. and then the context that we have for the function running. You can check how long it's been running, send error information to it, stuff like that. All I'm doing here is returning that message and hello world. There is a gotcha with serverless. All the platforms have slightly different syntax, slightly different. This one is for Lambda. Don't blink. This one is for OpenWhisk. Kind of similar, subtly different. The incoming arguments are slightly different. So there is a framework called Serverless framework, which aims to help you keep your code independent. If you don't know where you are deploying to, if you want to deploy to multiple places for redundancy, or if you don't want to be locked in to one particular cloud provider, then that framework will help you, and I have a link in my slide deck. So that's the code for OpenWhisk. Let me show you the rest of the moving parts. Again, there's a command line tool. We're going to use the Bluemix BX command with the Whisk plugin. So again, I zip it. It's a traditional Python zip file, so this time it's going to be called __main__.py. And then all I do is I can, on the first upload or on later uploads, use the same command, quite like this, programmers are lazy, and just call update. If it doesn't exist, it will create it, saying, it is Python, please use Python 3. This is the name of my function. This is package name / function name. OpenWhisk gives you packages. You can group actions together inside those packages. You can also attach parameters to the package at deploy time. So if you have a bunch of actions that need access to the same parameters, that's a tidy way to do it. To run it, invoke it. Oh no, first of all, we zip it. A little bit about dependencies in Python. The best thing to do, some of the really, really mainstream libraries will be available on whichever serverless platform you choose. To include something that isn't, you're going to use a virtual env and then just include that in your zip file. So if you have, and that's nice because you know what version of the libraries you have and everything, and then you can push that. To invoke it, you're going to do bx whisk action invoke. I'd recommend the -- blocking switch before the name of the action. Without the -- blocking switch, your action will run, which is exactly what you asked it to do. Computers often do exactly what we ask them to do. However, if you would like your command to wait for a response and then show it to you, as opposed to just order it happen and then forget, then you need that -- blocking switch to keep the connection open while it runs. A really nice feature about OpenWhisk, and this is in the open source version, not just on the IBM cloud, you can add this --web true to your action update command, and then you can immediately curl your endpoint. You could ask it, what's your URL? And then you can curl it. All of the serverless platforms have these lovely API gateways where you can do the equivalent of a micro framework. If you think of Flask, where you register a URL and you write some function code, when this pattern happens for this route, do this. Each of your functions will do that. You can wire it up with API gateway in front of it. Pretty URLs, sensible joined up URL scheme, authentication, all sorts of things. But if you're just webhooking to a serverless endpoint, yeah, go for it like this. Your Slack bot can hit it, your form can post to it, and so on. So it's very easy to get started with. So, let me have an attempt at showing you some fun. And for this, I'm going to create a serverless action, which is triggered by the Amazon Echo dot. So, if you are not familiar with the Echo, they come in small, large, and something with a screen that I don't own. I'm not sure about that one. You speak. When you say the wake word, then it starts processing the sound, sends the sound to the cloud, and works out what you're trying to do. It definitely does not listen all the time and record everything that's happening inside your house and stream it to Amazon. That's definitely not happening. It definitely only listens on the wake word. I've read all the marketing material. I do have these in my home. I have them in the office. I have them in the kitchen. I don't have them in the bedroom. It's just how you feel about it. Okay, so to make this device, whose name I must try not to say, because then she talks back to me, you need to use quite a formulaic approach. So first of all, you say her name, then you say ask or tell, then the invocation name. This is like the app. It's called a skill in Amazon Echo world. And there's a marketplace where you can get skills. You can also write your own skills. If you only run them in beta on your own devices, you don't need to add all the security checking or anything. You can just run them. It's marvelous. So ask or tell, invocation name, and then you need to say which thing you would like it to do. So that's going to be, in any other context, it would be a function name, but because this is Amazon's proprietary platform, it is the intent. So which thing should happen? And then all of the other variables can't be called variables. That's not how this technology works. They're called slots. So you can either supply those at the time that you give the command, or the device can prompt you for the extra information, depending on the setup. We're keeping it very simple today because I don't have a huge amount of time. The code for this is on GitHub. It's also linked from the final slide. And all it does is it's a simple piece of Python which looks up, given an airport code, where is that? I fly a lot. This is a genuine problem to me. Alexa, ask Airporter which airport has code CWL.
Airport code CWL is for Cardiff International Airport in United Kingdom.
There we go. Queen of the dramatic pause today, I see. Okay, so what's actually happening here is I have a Python function that looks up a bunch of airport data that I just rammed into a Redis. We have a bunch of storage things. Redis is one of my favorites. It seemed appropriate for such a lightweight application. And here is basically all of the code kind of squidged onto one slide. This is to give you an idea of how hard it is, how involved it is to build something like this. All of the code fits on one slide. You can go to GitHub and get my complicated instructions of how to parse CSV files and put them in Redis. That's the hard part. Once it's in, it's super easy. You can run it on your own Echo device. So I'm importing the Redis client, defining a main function. It's got some args. I madly abbreviated line 4, which is where I parsed out the Redis CLI and set up the connection and everything else. It's not very interesting. On line 5 is where we parse the data that came in from the, don't say her name, Amazon Echo data structure. Don't say her name, don't talk to her. So you get a request object. You can see inside the intent the slots, and you can check. The slot has a name, code, and then it has a value. And that will be the 3 letters that I spoke. Hopefully, usually. She's not very good at capital letters. Luckily, the Cardiff one works quite reliably. And then we can have the airport information. So in the Redis client, it's stored as a hash. So I have hgetAll, and then the key that I'm looking for. If you're not familiar with Redis, it's an in-memory with optional persistence key value store that understands multiple different data types. It is awesome. If you're not using it, I guess see me after, because I'd like to talk more about Redis. Okay, we get the airport information and we build the string if we want her to say. So we say airport code, and she repeats what she heard me say, which sometimes isn't totally what I said, and then tells me the name of the airport and which country that is in. And this last part is Echo framework specific. So we just say you can do type, I forgot what it's called, some kind of expressive speech with markup when you're working with these devices. I'm a back-end developer. That seems like presentation logic. I'm using the plain text version. Sorry. You can put commas in and anyway. Should end session true, meaning this conversation is over. I have a few longer ones where she prompts me for slots and stuff. That's quite interesting. Send that speech that we built up there, and then just send the response and the version. Serverless, it's a trivial example. I'll admit it's a gimmick. But it shows you there's a bunch of things you can do here. You can call out to data stores, you can call out to APIs, you can run your functions in response to events happening elsewhere in your system or in other systems with data appearing on different types of feeds or other kinds of push notifications. Hopefully this has shown you that there is a lot that you can do, and also that it's very approachable. You don't need to be any kind of expert programmer to manage this. If you're going to build very large and complicated applications with this sort of setup, then you definitely need some tools to keep track of it all. But to begin, or to build something that is relatively small and manageable, all of you could do this tomorrow, or, sit with me over lunch, whichever. It is a revolution. We will start incorporating things like this, not just into our microservices, but also into other parts of our applications. I think we'll be talking about this for a long time to come. I also don't think it's 2018's revolution. I think it's 2017's revolution. I am seeing this in actual industry applications already, all the time. I'll tweet a copy of this because I'm conscious that I'm running out of time. Go and have a play with Cloud Functions. Here is the GitHub repo for the demo that you have just seen. OpenWhisk is an open source project, so if you'd rather play with it locally or on your own servers, you can. Redis is awesome, and if you want more content like this, links to videos and stuff, go to lornajane.net. Thank you very much.